Hello viewers, my name is Teacher Kamanga. This is a mathematics learning video. I'll be taking you through the topic indices and logarithms. This is a Form 2 topic. I'll show you the formulas that you need to apply in this topic, and as well as solving examples for you. And then I'll give you an exercise for you to try out whether you have understood or not. After that, I'll also be able to provide the answers which will guide you whether you have understood what we have covered, and much more. You are welcome to watch other topics that I have produced. So you are very much welcome. So in this topic, we are going to learn indices and logarithms. The content of this topic are: number 1, indices; number 2, rows of indices; number 3, powers of 10 and common logarithms; number 4, logarithms of positive numbers less than 1; number 5, applications of logarithm. So I hope you are going to enjoy the topic. A good teacher is like a candle. It consumes itself to light the way for others. So we are going to look at what are indices. This may look like it's a new term, but if you are in secondary school, you have already used what is referred to as indices. We all know what is 3 to power 5. What it infers is 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. That is 3 multiplied by itself 5 times. So we refer to 5 as power. We refer to 5 as power. And we read this as 3 to power 5. Actually, index is another word for power. So 5 can also be referred to as index. So here we can read 3 to power 5, which is the same as 3 index 5. When we have 2, 3 index, that is in plural, we refer to them as indices. So indices is plural of index. Let's take an example. We may have 2 to power 4, 3 to power 6, 4 to power 2, and 5 to power 3. So here we have now what we refer to as index. So we can say 4, 6, 2, and 3 are indices. The other number, we have 2, we have 3, we have 4, and 5. So 2, like 2 to power 4, this is index, and this number is referred to as base. So when they are more than 1, then we can say this is a base, this is a base, this is a base, and this is a base. So 2, 3, 4, and 5 can be referred to as, in plural, bases. So that is what is the meaning of the term indices. It is a plural of index, and index is the same as power. So, like I had mentioned, it's something that you have dealt with in the past. So the three rows of indices are: the first one, a to power m multiplied by a to power n is equals to a to power m plus n. The second row of indices, a to power m divided by a to power n is equals to a to power m minus n. And finally, the third row of indices, a to power m into bracket to power n is equals to a to power m multiplied by n. So after using these three rows for some time, you'll be able to understand them and be able to apply when they are needed to be applied to solve a certain problem. Now we are going to look at the three rows of indices, and we are going to use examples to derive them. So we consider these three situations. So consider number one. Suppose we have a cubed multiplied by a squared. So we can write this: a cubed is the same as a multiplied by a multiplied by a. Then a squared is the same as a multiplied by a. So in total, if we count 1, 2, 3, 4, 5, it is equals to a to index 5. We take another scenario. We say number 2. Let's have a to power 7, a to power 7 divided by a to power 4. So we can write this: a to power 7 can write a multiplied by 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 a 7 times. 1, 2, 3, 4, 5, 6, 7. All of this divided by a to power 4, which is a multiplied by a multiplied by a multiplied by a. Since a is common, we can divide a by a, get 1. Divide a by a, get 1. Divide a by a, we get 1. A divided by a, we get 1. So we will be left with 1, 2, 3, which is equals to a to power 3. Now we go to the third scenario, where we have a to power 3 into bracket squared. So this is equals to a cubed multiplied by a cubed, which we can write a cubed is the same as a multiplied by a multiplied by a. Then the other a cubed, you also multiply a by itself 3 times, a times a. So if we count 1, 2, 3, 4, 5, 6, it is equals to a to power 6. Now, from the three examples we have used, we can see, or we can derive, the three rows of indices. Let's start with the first one. If we look at 3 and 2, when we are multiplying, when you add 3 multiplied by 3 plus 2, you get 5. You get 5, which is the final index in this case. Therefore, we can conclude the first row of indices, when the base is common, we can write it in short and write a to power 3 multiplied by a to power 2. Instead of writing it in expanding it, it is the same as a, then we add the indices which will give us a to power 5. From this, we can derive the first row of indices and say, if we have a to power m multiplied by a to power n, it is equals to a m plus n. So that is the first row of indices. The first row of indices. So we go to the second one. In the second one, you can observe 7 and 4. Here we are dividing. When you subtract 4 from 7, you get 3. So we can write it like this. The second row of indices, we have a to power 7 divided by a to power 4, which has given us the result a to power 3. So we derive the second row of indices, which is, if we have a to power m and we are dividing with a to power n, it is equals to a m minus n. So that is the second row of indices. Now we go to the third one. The third one, we have a to power 3 into bracket squared. You see, when we multiply 2 times 3, we get 6. Therefore, we can say a to power 3 into bracket squared is giving us a to power 6. And therefore, the third row of indices is a to power m into bracket to power n is the same as a to power m multiplied by n. So this is the first row, or the first row of indices, the second row of indices, and the third row of indices. So we are going to look at a few examples, but before we go to that, there's something we need to note. Now that we know the 3 rows of indices, these rows, it is important to note that these rows are only applicable when the base is common or is the same. For example, if we have 2 to power 4 multiplied by 2 to index 2, then 2 is the base, and therefore we should be able to apply the first row of indices, which will give us 2, 4 plus 2, it is equals to 2 to power 6. But if we have a row, if we have an expression like 2 to power 4 multiplied by 3 to power 2, because the two bases are different, we cannot apply the rows of indices. So here you cannot apply the rows of indices, but you can do it here. So note that. So before we learn what is zero index, I have a good quote that I like. It says, give a man a fish and you feed him for a day. Teach a man to fish and you feed him for a lifetime. This quote is from a person known as Maimonides. The zero index. Maybe you have heard people say that anything to power 0 is 1. Anything to power 0 is 1. That is the zero index statement. Anything to power 0 is 1 and can be illustrated using the second row of indices. Let's take an example. Suppose we have a to power m. We divide by a to power m. The second row of indices tell us that then this is the same as m, a to power m minus m. And since m is common, this is the same as a to power 0, since m minus m is equals to 0. On the other hand, we can say that we can express this expression in another way and say a to power m divided by a to power m is the same as a to power m divided by a to power m. A to power m divided by a to power m, we get it is equals to 1. Now, since we are expressing the same statement, then it means that this is the same statement. Then it means a to power 0 must be the same as equals to 1. And therefore, this is what we refer to as the 0 index, that a to power 0 is equals to 1. And from this, we say that 10 to power 0 is equals to 1, 1,000 to power 0 is equals to 1, 1,000,000 to power 0 is equals to 1. Now that we have learned the rows of indices, I'm going to do 2 examples, but later on we will do more, just to demonstrate how we use the 3 rows of indices. Now, we are told to evaluate a to power 8 multiplied by a to power 2. So in this case, because it involves multiplication, we are going to apply the first row of indices. And this row said that a to power m multiplied by a to power n is equals to a m plus n. And therefore, our equation here, or our statement here, we can write it like this: a to power 8 multiplied by a to power 2. Since they have a common base, then this can be written as a 8 plus 2, which will give us a to power 10. We come to part B of this example. We are told we divide 4 to power 4 divided by 2 to power 2. We cannot apply any row of indices because the base are different, but still we can manage to divide. So this is 4 multiplied by 4 multiplied by 4 multiplied by 4 divided by 2 multiplied by 2. So this 2 divided by 4 is 2. We divide 2 by 2, we get 1. So we have 4 cubed, which is equals to 64. So note here that we have used the wrong method because we cannot apply any row of indices. Part C, we can apply the third row of indices, that states that a to power m into bracket to power m to power n, not m, is equals to a to power m multiplied by n. You don't have to write the row all the time, but just doing that so that you be able to follow. But once you understand, you just need to apply directly. So we have 3 to power 2 multiplied by, or to power 3. This is equals to 3 2 multiplied by 3, which is equals to 3 to power 6. So that's how you work out that problem. Example 2 we have, so for x, we have 3 to power 2x into bracket to power 2 is equals to 81. For us to be able to get the value of x, we apply the third rule of indices in the left side of our equation here. So we have 2x multiplied by 2 is equals to. On the right hand side, we write 81 in powers of 3 so that we have a common base, which is 3 to power 4. Simplifying here, we have 3 to power 4x is equals to 3 to power 4. Now you note that the powers or the indices are the same. 4x and 4 have a common base. Therefore, we can equate the indices and say 4x is the same as 4. Divide both sides by 4. Divide by 4. 4 divided by 4 is 1. 4 divided by 4 is 1. And therefore, our x is equals to 1. And if you substitute, you find 2 times 1 is 2 into bracket squared. That will be 3 to power 4, which is the same as 81. Come to the second question. We do the same. We open the bracket by applying the third row of indices. So we have 3x multiplied by 2 is equals to 496 is the same as 2 to power 12. You can find that using a calculator or mathematical tables. Now this, when you multiply, you get 2 to power 6x is equals to 2 to power 12. Now that we have a common base, which is 2, we can equate the indices and say 6x is the same as 12. Divide both sides by 6. Divide by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. So we have our x is equals to 2. So that is how you work out such a problem. So get answers for the given exercise from Teacher Wamta YouTube channel. It is important you open a Gmail email account, like and subscribe Teacher Wamta channel so that you get all the lessons and revision questions that I have prepared. If you don't know how to open a Gmail account, you can get assistance from Cyber. Or if you know how to browse the internet, you can just go to www.google.com. Then you find an option of opening an email account. If you don't have one, you can use one. If you are a student, use your parents' account. You will be able to access these materials.